Okay, now on to the Gamma X pump. The pump has been released. It is available in our eQuote program. The cut sheets and information can be found on our website. I believe later today, early next week, you should see, if you're signed up for our e-news, a blast formally releasing that to the public. Okay. The pump has been released in Europe for a couple months now. We held back a little bit to make sure we had everything organized, ready to go, and we finally have that all ready to go, and we're ready to release to the market. This pump kind of, for us, is revolutionary. It makes a lot of changes, allows us to do a lot more than what we can do with some of our other pumps. The pump, if you're familiar with our Delta pump, the Gamma X is very similar to that pump, but it can also do even more than what that Delta pump can do. The Gamma X will eventually be replacing the Gamma L pump. We're not certain right now what time frame there is for the replacement, complete replacement of the Gamma L. We will still be building the Gamma Ls for the time being and be able to service those and provide repair and parts for those. Okay. We have the line completely set up right now. We're just waiting for some orders. We do have some orders coming in, and we're putting the pumps out as fast as we can. The line is right next, if you've ever been to our factory, the line is right next to our Gamma L line in production. One of the main differences between this pump and any pump we've had to date so far, and you'll kind of hear me talk about this and mention it numerous times throughout this presentation, is that on this pump, the stroke length, that is the dowel typically on the front of the pump, to date, all of our other pumps, that stroke length has to be, we're mechanically attached with that knob on the front. So with the Gamma X, that knob on the front is actually a wheel that spins to do selections on the menu. Some of your higher end cars these days have those on the console. You use that to navigate through some of the different menus on those screens. That's what this is going to do. It's a turning wheel that spins, and then you can press it in to confirm selections. So with that being said, we're no longer mechanically attached to the solenoid. Okay, there now is a board on the solenoid, and then there's a laser on there that reads markings on a shaft that knows where that stroke length is set. As we get into more through the presentation, I'll tell you how that gives us a huge advantage with not being directly coupled to that solenoid any longer. Okay, some of the features of the pump. We now have a very large illuminated high resolution LCD on it. You can see that picture to the right. It's about 2.5 inches wide by about 1.75 inches tall. It's very bright. You can change the brightness and the contrast on it. It's easy to read from even a little bit of a distance. Okay. With this pump, like the Delta, we can control the suction and discharge, the duration of how long it's going to take to do that suction stroke and that discharge stroke. We have some different modes to manipulate that suction and discharge. We go even farther than what the Delta had and have a couple more features we can do with the discharge stroke, and I'll get a little further into that as we go on. Integrated pressure measurement. Our competition pumps, they have built-in pressure switches into the head of the pump, which could potentially see chemical attack. Our pump is going to, when we program it here at the factory, we put the programming in. The pump creates an energy profile, very similar to what the Delta did, if you're familiar with that. So we no longer have a switch of any type. We create an energy profile. How that works is if we're pumping against pressure and the pump's pumping like it should, everything's going good, all of a sudden it's taking more energy for that pump to make that pump work as it's going. all of a sudden it's harder for it to do, meaning it has to make more energy to do that. That most likely means we may have a blockage in the line. Somebody may have come up and shut a valve somewhere. It's harder for that pump to pump. So we go into what we call a P plus error. That's an overpressure, just like the delta. Kind of along the same lines, if we're pumping normal, all of a sudden it's taking less energy for us to pump. That could mean that there's potentially a broken line somewhere, and that reduction in energy would be recognized as a P minus error on the pump. Okay. Next, you see the detection of hydraulic problems. I mentioned the overpressure, the no pressure. We also are able to detect any gas in the head. So if we're pulling in any air through the line, the pump will recognize that and try to evacuate that air throughout out the head. Ways to get rid of that air in the head: we have diaphragm rupture. We have auto degassing options for the pump. There's numerous different options available on this Gamma X pump compared to some of our others. If you're familiar with the Delta, again, the only option for auto degassing on that was a rather expensive solenoid option. Okay, that option is also available on the Gamma X, but we also have now the acrylic head with the 3 valves on it, our normal auto degassing that was available for the Gamma L and the betas. So that head is also available, typically ordered as our NPE 9. If you're familiar with our ident code, that would be the 9 option. So we have the solenoid, we have the 3 valve degassing option, and we'll also be adding a third option that we're still looking into. It will be referred to as the PVT7. It will be the 7 option if you're familiar with our ident codes. It will be a Kynar, the PVDF head. This is something we're just releasing now. It will be available on the Beta, the Gamma L, and the Gamma X. How it works is I'm still working on getting some drawings made up to some visual aids for it. But the PVT7 head has, it's the same exact head as your normal Kynar PVDF head. The suction valve is the same. The head block is the same. The only difference is in the discharge valve. If you're familiar with our valves on our smaller pumps, there's kind of 2 cartridges in each valve. Okay, each one of those cartridges houses the valve ball and a seat. So on the discharge valve of the PVT7 heads, the seats are machined a little different than your typical seats. They actually have real small slots in them. So in both of the cartridges for the discharge, there's going to be 2 slots in that seat. So while we're doing that discharge stroke and suction stroke, that discharge valve never gets a true seal. So we'll be that allows us to push out some of that air, and it won't allow the head to be airlocked. You'll see with that, when we go into the capacities of this Gamma X in a couple slides, we'll see how, if you're familiar with the 9 options for the auto degassing, you know that derates the flow. Well, this PVT7 option derates the flow even more than that 9 option, and you'll see the charts in a couple slides. The main advantages to that PVT7 option is you no longer have to have a separate line for the vent to go back to a tank or to worry about routing back to somewhere like you do with the current 9 option. So with the Gamma X, we'll have 3 different options available for auto degassing. You see this pump does have diaphragm rupture detection. That sensor is very similar to the same sensor we use on the Delta pump. It will screw into the back plate of the head, and then the cable will run to the front of the pump. If we were to detect a rupture of the diaphragm, the pump would send a signal, that sensor would send a signal to the pump, and then we can program the pump to either give us a warning or an error. So we can have it either just give us a warning that tells us, hey, it's ruptured, but I'm still going to pump, or we can have a complete error which will shut down the pump. Now, if I have a relay equipped with that pump, that relay can send a signal out to somewhere where an operator wants to see it, and they'll be aware of that rupture, and they can fix that right away. Kind of talked about the navigation wheel already. You see it to the right there in that bubble. This wheel, again, like I mentioned, is not coupled to the solenoid at all. It freely spins. It's going to allow us to navigate easily through the menus, through different screens, and then to confirm selections. Next, you see that simple adjustment directly in gallons per hour. We now, with this pump, and I'll get a little more into this in part 2, which is next month, we have an automatic mode on this pump. Automatic mode works in manual mode. It works in analog, batch, contact mode. What it does is I put the pump into automatic mode. Once I do that, if you're familiar with our pumps, on the screen you usually are able to see the stroke length and the frequency on the main screen when you're navigating through. When I put the pump into automatic mode, it takes those selections away from me. I can no longer see what the pump's frequency is doing or what the stroke length set at. What automatic mode does is on the main screen, it's going to show me in gallons per hour what the pump is set currently at the pump to pump at. Now, you don't need to do a calibration for the automatic mode. The further you do get away from the chemical being like water, viscosity-wise, specific gravity-wise, you want to start thinking about doing a calibration. But if the chemical's similar to water, calibration is not necessary in automatic mode. Once I put the pump into automatic mode, you're now just adjusting the pump in gallons per hour. Okay, so I'll have the pump set up to do 1 gallon an hour. I no longer can see, the pump won't even let me see what the stroke length is or what the frequency is. When the pump was programmed, when Germany developed this pump, they know that they know what the appropriate dosing profile looks like. So based on that pump model and the capacity you enter, it's going to be able to meet and give you the best possible dosing profile for that. Okay, and depending on hydraulic changes and different changes in the system, the pump is always adjusting that stroke length and frequency. So it doesn't want to see you, let you see any of that. Also, in automatic mode, it will compensate if the pressure changes, varies a little bit. It will adjust the frequency to meet that. Okay. Same along with analog. What's real big with automatic mode and analog, with all of our other pumps to date, if I set it a 4 to 20, that 4 to 20 only adjusted the frequency of the pump, how many times per minute we stroked. Now with automatic mode in the Gamma X, I set it a 4 to 20 mode, 4 to 20, it's going to adjust both the frequency and the stroke length for us. So it's going to allow us a larger turn down in analog mode. Before, if somebody was running at 50% on the stroke length and they were setting it a 4 to 20, and for some reason some sort of event happened, the pump needed more, they would have to go out there and physically adjust the stroke length. That's no longer necessary with the Gamma X because, as I mentioned, we're no longer directly mechanically attached to that solenoid. Okay, so that's a huge feature. We also, in batch mode, we have the ability to set up a batch, and it will ask us how many gallons we want to batch, and then it will also let us pick how long it's going to take us to do that batch. We can enter an actual batch time. The pump won't let you due to if the pump can't match that batch time, it won't let you do it. It'll let you know that the capacity in that amount of time is too much. Okay. Virtual wear-free solenoid. Really, with the solenoid-driven pump, you only have one wearable item in that solenoid, and it doesn't really wear out at all. Wear on it is very minimal. Our competition, in order for them to get the ability to adjust the stroke length and manipulate how fast and slow that stroke length is, they use stepper motors, which have a lot of gears. They have a lot of bearings in them that are more moving parts that go wrong. Okay, that overload proof bullet point there is kind of going back to the hydraulic, the ability to detect hydraulic problems. We do have a removable base plate. So typically, if you're familiar with our pumps, they have kind of the ear tabs sticking off the bottom of the pumps. We've gotten rid of that. You'll see it in further slides. There's now a base plate that slides into the bottom of the pump. That base plate has numerous mounting holes on it, and those mounting holes are the same mounting holes as the same pattern as a Gamma L pump. Okay, so if somebody has a pump stand and they have the holes already for the Gamma L, they can slide this pump right in there. Okay, I will tell you that the center line of the head is slightly off from the Gamma L. This is the pump is slightly higher. We're only talking fractions of an inch. It shouldn't be that much of a problem. Most of our skids that leave here with smaller solenoid pumps, they are plumbed with tubing. Some more of the technical features. I have here the turn down is 40,000 to 1. I don't want to get anybody too hung up on this number. That is a theoretical turn down. I would strongly advise that no one tries to turn down to 40,000 to 1. That is running at 1 stroke per hour, and we can set that up so that is 1 continuous stroke an hour, and that would be running at 30%. Okay, on the stroke length. That's a large turn down. I would feel comfortable saying that this pump could be very repeatable at even a 2,000 to 1 turn down, which is still a huge turn down. Okay. Repeatability is that plus or minus 2%. Our pumps are usually more accurate than that. That's kind of just the industry standard for mechanically actuated diaphragm pumps. Okay. The rating on the housing is IP65. Okay. The 6 stands for it's sealed so no dust can get inside. The 5 means it can take a low pressure shower of water. I would still try to protect the pump the best you can. Keep it out of the weather. None of our pumps are throwaway pumps. I wouldn't want to spend the money that our pumps or competition is charging for our pumps and say they're throwaway. Ours will last. That being said, I would recommend they're put under some sort of protective cover. Going back to the way we can manipulate the discharge stroke, we have now, there's 5 different modes there. We have an optimum mode, we have a fast mode, we have a sine mode, which is the sinusoidal curve. We have a continuous discharge, and then we have a mode for the DFMA. That DFMA is our Dalco flow. So when Germany developed this pump, they know that that pump likes to see, it needs to see a pulsing flow. Okay? And they know the profile that that pump really needs to see. So if I were to put a Dalco flow on this pump, I would recommend you use that discharge mode. Okay? You have a fast mode, which is going to make the discharge go as fast as you can. That sinusoidal mode gives you a nice bell curve up and down. consistent discharge suction stroke. Continuous would be if I'm running the frequency down really low, I can have it do continuous discharges. Like I said, the pump can theoretically do 1 continuous discharge stroke an hour. Okay. With that being said, you'll see that the diaphragm movement is 1.5 millimeters. You'll need to keep that in mind. That is less than, that's somewhere around a 1/16 of an inch. So we're not moving that diaphragm very much. That gives us an advantage that will prevent a lot of wear of the diaphragm. Okay. But at the same time, to move all that fluid, we're only moving a total of a 1/16 of an inch on our suction or discharge stroke. Okay. We do have, like the Delta, if you're familiar with the Delta, on the suction, we have our normal modes, and then we have our HV modes. Those HV, that's what HV stands for, is high viscosity. We have 1, 2, and 3. Now keep in mind, on those HV modes, as we pick those, it derates the capacity of the pump, just like the Delta. This pump can do a maximum of 200 strokes per minute. The Gamma L was 180, so we did up the maximum strokes per minute we can do with this pump. Once I pick HV1, it derates the pump down to, I believe, 160. It's either 160 or 180 strokes per minute. HV2 derates it even more, somewhere around 120. And then HV3 derates it even further. Okay, that would be for trying to pull in polymers, anything that has that high viscosity. It's going to do a very slow suction to make sure we completely fill that chamber on the pump. Okay. Liquid end materials, nothing has really changed here. Your typical liquid ends that are available on the Gamma L and the Deltas. You have your polypro, that's PP, PVC, it should say PVC/acrylic. We have the acrylic head, they have PVC valves. PVDF is that white material, it is Kynar, stainless steel, and then Teflon heads. As of right now, the stainless steel, I believe, is not available. It should follow very shortly with the release of the stainless steel heads. They're still doing some testing on those. Inputs and outputs of the pump. You still have your manual, your contact and batch, your analog. The timer function is available on this pump. It's a lot easier to program than if you ever tried to use it on the Gamma L. The pause function, one thing I'll mention with the pause function, if you're familiar with our universal control cable, that cable is still used on this pump. You now have the ability to change it from being normally open or normally closed. Okay. So in the past, that brown and black wire had to be together or the pump would be in pause. Now I can change it so that brown and black wire can be open and the pump will be out of pause. Okay. Just more flexibility for SCADA operators, some of our guys that are doing the programming. That auxiliary frequency is now, if you ever use that, we're only able to adjust the frequency with that. We can now have it adjust the frequency and the stroke length. So I can make that go to a true 100%. Okay. The level switch, it is a 2-stage level switch we can put on the pump. It's the same level switch used on most of our other pumps, but we can now change it to be normally opened or normally closed also. Okay. Outputs. You have your fault indicating relays with pacing analog, and then you have that degassing module we mentioned earlier. You have the option to get that degassing module with the fault indicating. I would probably recommend you just try to stay away from that degassing module just because we have 2 other options that work great for us. That would be the 9 option 3 valve and that new PVT7 head. So I'd try to stay away from the degassing module as much as possible. That is the module that the Delta has with that solenoid. Okay. Communication. I'll tell you that Germany is working with an independent company that they are trying to come up with a bus card that accepts any type of bus communications. That is still in the development. The only bus communications we have released at this moment are Profibus. Okay. They released Profibus a couple weeks ago. Right now, that is the only communication available, but they are actively working on Modbus, CAN-bus, Profibus, Profinet. Okay. Next is Bluetooth. Something that is new for us here is Bluetooth communication with the pump. It's a pretty neat feature. This is something that needs to be added when you're doing the ident code. Okay. Once I have that, I will tell you that it is right now only available for Android phones. Okay. You can find it in your Play Store if you type in Prominent. Two apps should show up. You'll want the app that says Gamma X on it. Even if you don't have a pump, you can still download that app, and there is a simulation mode so you can get an idea of what's able to be changed. And once you're in there, you can change a lot of different modes in the pump. In that simulation mode, it's going to ask for a password. In simulation mode, you can put in any password to get into the next menu. If you have an actual pump in front of you, you would go into the programming, turn on the Bluetooth mode, sync it with your phone. When it asks for a password, the default password on our pumps when they leave the factory are going to be the last four numbers of the serial number. Okay. Once you're in there, you can pretty much change a lot of the settings in the pump. You can change the dosing profile, how the suction and discharge strokes are manipulated. You can change the frequency of the pump. You can change the stroke length. You can put it in and out of automatic mode. You can also see errors on the pump on there. What this helps us with is Bluetooth usually about 30 feet away. That's kind of limitations. Block walls hinder it a little bit. But if the pump's in a room where it's closed off, sometimes you need to get permits to get into that room. If I can link up to it outside of that room, I don't have to try to file for that permit to get into that room. So Bluetooth is available. It is a selectable item in the ident code. Android only. From what I've heard is Android has the market in Europe, and the card needed to put Apple on it was rather expensive. At this point, I don't know if they're going down the road for Apple. We'll just have to wait and see what their thoughts on that are. Here you see some of the dimensions. The pump, like I said, is a little bit larger than the Gamma L, but at the same time, it is right around the same weight. Okay, so it's if you've ever picked up a Delta pump, the Delta pump can weigh somewhere around 30 pounds. This pump at max, we're talking 10 to 11 pounds with a stainless steel head. That's very similar to what the Gamma L pump has. You do see on that right picture the removable base plate that clicks in and out. That makes it easy to take the pump out of service. Here is a look at the capacities the Gamma X is capable of. And notice, like I mentioned earlier, we now have three different charts. We have your standard liquid ends. Below that, we have with the auto degassing, that's the 3 valve, that's that 9 option, the NPE 9 you may be familiar with. And then even down further, we now have that PVT 7 head. So keep in mind, if you're selecting one of those heads, it does derate the capacity of the pump. Let me also throw this at you. If the pump is programmed with one of the auto degassing heads, you will lose automatic mode on the pump. Okay, so automatic mode is disabled when the pump is equipped with one of the auto degassing liquid ends. The reason for that is at that point we don't really know how much we're losing due to the off-gassing, so we can't say we're actively metering, so automatic mode just doesn't make sense at that point. Okay, you can still do a calibration and route your vent back to the calibration column to account for that loss, and once it's calibrated you'll have a theoretical readout on the screen. But that could always change depending on the temperature, the quality of the chemical, how much it's off-gassing at that certain time. Okay. You'll see, like I said, on this chart, the Gamma X is capable of 200 strokes a minute. You'll see to the left, most of these heads have crossed over from the beta pump. So a lot of the spare parts, a lot of the head completes come from the beta pump. There are 3 new models, the 0424, I believe the 0245, and then I think it's the 0414. Those are completely new heads for the Gamma X. You'll notice the maximum of the pump, the Gamma L, I believe the maximum is somewhere around 8 gallons an hour. This is higher with almost 12 on the Gamma X. So we start going in even to the delta range, even though the pressure, you have to keep in consideration the pressure's not all there. Okay. The lower end doesn't go as low as the Gamma L did with the 1000 model, but we have a much larger turn down, so we can turn this pump down much lower than what we can the Gamma L. So this pump will go well into cover everything the Gamma L could do, and then even start going into what the Delta can do. Okay, you see some of the connections there that are there. If you want to mess around with the ident codes, you can use our eQuote program and kind of see what the selections are. This shows you the front of the pump. On the front of the pump, we'll kind of start at the bottom. The front card in the front, there is a removable base plate on there. That's where our modules will go for Profibus. That is where our relays will go. On the Gamma L, that's an actual knockout on the back of the pump. It is a gasketed one. This one has a real nice gasket on it and a replacement panel. So if they decide to take out a relay, they can put this cover on and replace it. Okay. Underneath that cover, there is also a port to plug in a micro USB cable. I can go from micro USB to a regular USB, plug that into my computer, and if there are any type of firmware updates, we can email those updates to you, and you can directly throw them into the pump. Those updates would be, if for some reason we found some sort of bug, we could update the firmware for that. We would not be able to send out any type of upgrades. If the pump wasn't ordered with analog, I cannot send that out through that cable. Okay. You have 4 ports there on the front. You have your diaphragm rupture indicator we talked about. You have your external control. That's your 5-wire universal control cable. That metering monitor is our typical metering monitors that sit directly on the discharge. And then you have your 2-stage level switch there. Okay. The buttons, you have a back button, start-stop button, and a menu button, which would be our P key on our auto pumps. You now also have a priming key. So on the Gamma L, the Delta pump, you have to hold the arrow keys in. That will take the pump up to the maximum frequency for priming. With this priming key we added, once I hold it in for about 2 or 3 seconds, it will initiate the priming sequence. It will start counting down on the screen, and we can adjust that priming sequence from anywhere from 1 second up to 60 seconds. As it's counting down on the screen, I can then turn that dial to either increase to keep going with the priming sequence or go down to end the priming sequence. And I'll show you that next week when I have a webcam on the pump to go through that. You hold in the menu button that will get you through the different menus, and you navigate with that navigation wheel that's there. There's the bright LCD screen. You do have 3 different areas that you have your top bar, your main middle bar, and then down below you have a secondary display where I can display different information, what the counters are doing, the stroke length, the frequency, what the 4 to 20 is coming into it if we're sending an analog signal. Okay. Next, you kind of saw this labeled on the last slide, the LEDs for the status of the pump, the fault indication of the pump, are now at the very top of the pump. They are colored in the fashion of a stoplight, so green, yellow, red in that order, kind of if you're standing at a stoplight, that's how this is mounted horizontally. They are very bright. If I'm standing behind this pump and I'm 20 feet away, you can see the status of the pump. Pretty much from any angle, you can see these bright LEDs. That's a very nice feature of the pump. The green status light, which is a normal status if the pump's going good, will blink for each stroke, just like all our pumps. If you have it in, say, doing 3 continuous strokes a minute, which is very slow, it will stroke a steady strobing, letting you know it's doing that instead of strobing just every time. It will give a nice strobing, letting you know it is discharging. Okay, so those are very visible from any location. Next, this kind of gives you an animation of how the diaphragm rupture detection works. You have that, you'll see in the video, it looks like maybe something comes up, ruptures that diaphragm, whether it be a stainless steel shaving or any piece of debris, something abrasive has caused that diaphragm to rupture. It will send a signal that is not fluid. That red signal going through there is not fluid. That is just a representation of that signal going to the pump. Once it goes to the pump, we can now, like I said earlier, have that pump go into a warning or a fault. Okay. And then if your pump has a relay, you can send that out to let the operator know it's time to change that diaphragm. Another nice feature of this pump, you'll see this animation is a German animation, so you'll see that all the units are in liters per hour or bar. Our pumps will come in gallons and PSI. So just keep that in mind. Don't get too concerned about that. But you'll see on the top right of the pump, there is actually a pressure readout. Ours will be in PSI. You'll see what the pump is pumping into. And it is very accurate. We had a pump running in our lab at somewhere around 58 PSI on our gauge, and the pump read exactly what the gauge read. So there's a lot of systems out there where people don't have gauges on their systems. This would allow us some flexibility in having somewhat of an idea of what that pump's pumping against. You also notice in this animation, kind of what's going on is you'll see that in the animation they'll decrease the pressure. If we decrease the pressure, it's going to be easier for the pump to pump, so it's going to put out more, so it will decrease the actual frequency. Along the same lines, if pressure were to go up, we will need to increase that frequency, so we'll compensate for that reading on the screen. Okay. I know that was kind of a lot of information on the Gamma X. Next week I'll have a part 2. If you think of anything, feel free to call our main line. Again, my name's Doug Britton. Give me a call. If anything comes up, even 2 minutes after we sign off here, feel free to give me a call. My email address is dougb, as in boy, at prominent.us. Feel free to shoot me an email also if you have any questions. Okay. We'll do this again next month, February 12th. I will have kind of a hands-on with me with a webcam on the screen. We'll go through the different screens. So if that automatic mode or any features I explained to you, you may still be trying to put those pieces together. I'll try to complete that puzzle in February. Okay. Again, thanks a lot for showing up.